So we have a 40-minute session. What we're going to do is we're going to go over the slides and talk for the first 20 minutes, and then we'll do some demos and then a hands-on section at the end. So if you have your computer, we'll walk you through how to use Qualcomm AI Hub, and you can try it out yourselves. If you don't, we'll still have time for questions, and you can try it on your own time later and let us know if you have any questions once you do try it. So. My name's Megan. I'm the product and program manager on Qualcomm AI Hub, and I have with me Bhushan, who is an ML engineer for Qualcomm AI Hub. So we're very excited to walk through today how to optimize, validate, and deploy your ML models on device. So I've already mentioned the agenda, but just a quick recap, because there is a break on the agenda in the middle of the session. We're not going to take the break, but we're going to end 20 minutes early. So hopefully that's okay with everyone, and then there's more time for questions at the end. All right, so first we'll talk quickly about why on-device AI. And if you're here, you probably know that AI is a very popular thing to talk about these days, and there's a lot of AI experiences in what you're doing every day. So it could be text recognition if you're scanning a photo and it picks up the text that's there. It could be object detection, if you're detecting if there's people walking by. There's so many use cases for it. There's the very popular large language models, which everyone seems to be talking about these days. It could be something as simple as your Roomba vacuum going around your house and detecting when it's gotten all the dirt. But regardless of what the use case is, we want to make it easy for you to deploy machine learning on device, and not just the advanced developers that have spent hours working on this large language model. So with that in mind, our goal is to make every product, application, and device more intelligent. And hopefully by the end of today's session, you'll agree with us that that's pretty easy to do that. So focusing first on why on-device AI. The biggest reasons here are cost, privacy, and performance. With your model being on device, you don't have to worry about cloud costs and constantly incurring costs regardless of which cloud you're using. There's some cost there. But if it's on device, then you don't have to worry about that. The next piece is privacy. So when users are using your application, if you have your machine learning model bundled on the device, then they can rest assured that their data isn't being sent to the cloud, it's not being used for multiple things, because they're leveraging the power of the device in their hands. And the last thing is performance, because they already have this very powerful chip that is in their hands, or maybe it's a laptop or an IoT device that they have already. There's no need to send the model data to the cloud and then wait for the model to run and then send it back. Because the model's on device, it'll run as fast as possible. Then you don't have to worry about any latency, any internet connection, because the model can just run on the power that they have. So with that, each device has a different chip, which of course has the CPU, GPU, and NPU. And what we've found is with machine learning models, they work best on the NPU and leveraging that capability. But if you have different restrictions depending on your model, maybe you're building a gaming application and you're already using the GPU intensively, then you can pass through different options to make sure that you're leveraging the compute unit of your choice. So you can pass through a flag that says CPU only or maybe NPU only, depending on the chip and the device that you're deploying to. So these are always things to keep in mind, and we'll show you how this can all be done with our platform as well. So a couple of things that we've seen in our experience of deploying machine learning on device is that it can get complicated pretty quickly. And there's lots of different challenges that you could hit. Whether that's how to create the model, maybe you finally got it working, but then you see that there's an op that's not supported. Maybe it's working, but it's taking too long, taking too much memory, or it's not even showing the correct results. We've been in this space for a long time, and believe me, we've hit all of these issues. And that's why we created Qualcomm AI Hub to help simplify this journey and to solve these issues so that you don't have to. So with that, we've targeted 3 specific user journeys and development problems that we aim to solve with Qualcomm AI Hub. So the first is getting started. We want to make it easy to bring machine learning on device. And with that, we have AI Hub to do all the hard things for you. So you just have to worry about what use case you're trying to solve and what device you're trying to deploy to, and not too much more than that. Of course, if you're worried about performance, maybe your model isn't as fast as you want it to be, then you can iterate on the model as well and work with us to make sure that it's running as fast as possible and it meets all your requirements. Because the last thing you want is to get this powerful machine learning application, and then when your users go to use it, it takes too long and it doesn't have that wow factor that you're looking for. Because we want it to be working well. Otherwise, there's no point, right? So those are some of the key problems that we're aiming to solve with AI Hub. So I'll just walk through the typical developer journey that we have here. And the first thing you'll do is pick a model. So we have over 100 pre-optimized open source models on our website, which I'll show you in just a minute, for various use cases. Now, if you go to our website and you don't see a model for the use case that you're interested in, you can also bring your own model. So you can take that model and you bring it to our platform and you submit a compiled job. And with that, you specify the target platform, so which device you're aiming to deploy to, the runtime that you'd like to use. So we support TensorFlow Lite, Onyx Runtime, and Qualcomm AI Engine Direct. And then you submit your model. And with that, we'll procure a real device hosted in the cloud for your model to run on. And we'll actually run that model over 100 times on the real device to make sure that we're giving you accurate performance measurements. So we want to make sure that the latency that you're seeing, that the memory that it's taking, that's something that you're going to be able to replicate when you bundle this model into your app. And from there, once you're happy with the performance, you can just download that target model and deploy it into your app. And we also have some sample apps that you can use as a starting point to take that model and get started right away. So just to give you a quick recap, we have over 100 models, which I'll show you, across our either bring your own model or picking one of these, and you can get started in less than 5 minutes. Now, I know that sounds a little ambitious, but hopefully once you try it out, you'll agree that it's quite simple. So before I show you the website, and then I'll hand it to Bhushan for a demo, I just wanted to share some of the exciting things that we've seen. So AI Hub launched in March, and since then we've had over 800 companies use AI Hub to optimize their machine learning models and bring them on device, which is of course great, but we've also seen over 99,000 models, and so these are the jobs that we'll teach you how to submit today to AI Hub from across 5,000 users. So if you think about it, if we get 1,000 people or even 10 of you to submit 100 jobs, then we could reach that 100,000 mark today of jobs on AI Hub. So things are growing pretty quickly, which is exciting. And then one more thing I'll touch on is our ecosystem. So we actually announced this last week, and we're excited to collaborate with all of the companies listed here to grow our support on AI Hub. So if you need somewhere to train your model before you bring it to AI Hub, you could use Amazon SageMaker. We have a blog out that details how to use both of our platforms, and we would encourage you to take a look at that. And you can also use Data Loop to use their pipeline and then deploy to AI Hub. Or sorry, bring your model to AI Hub to optimize it and then deploy your model. And of course, we have our runtime partners as well as model makers. So last week, we announced many collaborations with different model makers that you can see here. We have Llama from Meta, we have Mistral models, Preferred Network, and the list goes on. And we're excited to expand these collaborations as well so that any popular model that you're seeing out there is also available on AI Hub. So if you have any questions about any of that, please reach out to us, and we're happy to make sure that whatever models you're interested in are on AI Hub. So I'll just walk through the website so you can get a sense of what I'm talking about. So this is aihub.qualcomm.com, and what you'll see here is an overview of what I've mentioned, as well as our ecosystem partners, so you can learn more about any of them. So we'll just go into one, and I'll show you all that's there. So we have each ecosystem partner and then their models as well. So we aim to expand all the models that are here. But as it is, we have models also by industry, and these are the open source models as well as some from those model maker collaborators. So we have over 125, and then you can search here, let's say, for a computer vision model, and then let's say I want to do image classification. And it'll distill down the models that are applicable for that use case. And then we just click into one here, and you'll get details on the performance, because we run all of these open source models through AI Hub and give you a picture of how they would perform. So you can select whichever device you're interested in. Let's say we're interested in the new Snapdragon X Elite that was launched earlier this year, and then you can select the runtime that you're interested in, and it'll specify how it would perform. And we also have all of these models in our repo, which you can take a look at. You can run the export script, which gives you a good understanding of how the model works, but also walks you through how to submit these jobs that we'll show you in just a second. And then our demo.py, which gives you a demo of the model itself. So with that, I'll hand it to Bhushan to show you how it works.
Thanks. Thank you, Meghan. Let me just start it again. Cool. Hello everyone, I'm Bhushan, and this part of the session will do a brief deep dive about how AI Hub operates within, and we'll also understand how you can submit jobs on AI Hub to run those jobs effectively. We'll go over some of the demo that we have. We have some Android app demos set up here to walk you through the overall process. So let's understand how a developer starts and how you get a deployable model that you can readily deploy on the sample app. So on the left-hand side, you can see as a developer, and now the first step is to get a model, right? And as Meghan walked you through, there are two ways to get a model. You can directly go to AI Hub platform to pick up a model for your particular use case. But sometimes the use case might not be present there, right? Or you might have a use case, you might have a model, but you have a very specific requirement and you need to train your model. So that category falls into bring your own model. So in the first step, user gets a model either from AI Hub or you build your own PyTorch model. So once you have a model, you pick up a device, and once you pick up a device, you pick up a runtime. And runtime could be a device specific. For example, if you're targeting an Android platform, most of the time you have an option to choose from TF Lite, QNN runtime, or Onyx runtime. So these three options will be presented to you, and you can pick one from them. So from generalization perspective, most of the users that we have right now, they pick up TF Lite runtime, because that way you get an NPU acceleration on Qualcomm platform, and you can also get some other acceleration if you're not on a Qualcomm platform. So once you pick up a runtime, then you submit a compilation job on AI Hub. And what that does internally is it will compile the model. It will convert the model into an intermediate format. We do a bunch of graph optimization to make your model run faster. Just to give an idea about what type of optimization we might be doing, for example, you have two operations which are, let's say, doing 3 plus 2. But during compilation time, we know it's a constant. So we just replace that with 5. I was just giving a very simple example. But in machine learning land, you can scale that to multiple of fusion and other optimizations, which actually makes a huge difference in end-to-end performance of the model at the end. Once you optimize the model, then the next step is basically quantize the model. That's also one of the other jobs that you can submit via AI Hub. And once the model is ready to deploy, AI Hub procures a physical device from our device farm. Note that at this point, your model is running on an actual device, and it's not a simulation. The reason we need to run this on an actual device to make sure the numbers that you show on the profile job are indeed an accurate number that shows how that model will perform on our real customer devices. And then AI Hub runs the model on device. And at the end of this, you have two options. You can either look into the performance, and you can also do numerical validation. Both of these steps are very critical to make sure your model is ready to go for deployment. Because now you are sure about the performance, as well as you know that the numerically model is valid, and users will see the results that you expect them to. But now, once you have an optimized model, what to do with it? That's where we also have AI Hub apps that will guide you on how you can use this model and deploy them on the, let's say, for example, Android app or Windows app. So in the next curricular section, we'll go over each of this field to go in more depth. So let's look into how do you submit a compilation job. A compilation job is as easy as submitting this 5 lines of code. So we have a Python client that you can use to submit this job. Let me just walk you through this API. So submit compilation job requires a path to a locally PyTorch model. For example, here we have MobileNet V2 model. Then as you saw in previous step, you choose a device. So here you specify device. For example, here I choose Samsung Galaxy S23. And in this particular job, I know that I'm targeting a Qualcomm platform. That's why I choose a model library for Android. That's why I choose a target runtime as QNN library arc64 Android. And then I also specify input specification because each use case might be different. So I know that, okay, I need an input image of 224. Once you submit a compilation job, on the left-hand side, you can see you have a PyTorch model, an Onyx model, that it can either come from AI Hub GitHub repo, or it can come from Hugging Face. Once you compile and optimize the model, you either get a TF-Lite model, Onyx runtime, or QNN model. In this case, you get the first one. Now, at the end of the first step, we have a compiled artifact, which is ready to deploy. The model that you get from compile model is actually indeed a final model that you can deploy. But that might not be enough. Now we want to see how this model performs on device. And that's where a profile job comes into picture. So what a profile job does, you get a target model from previously compiled model. Now you don't have to download and re-upload the model. We just use the handle that compile job gives to us. And now you decide which device do you want to profile this model to. Imagine when you compile a model, you don't want to compile a model for each individual device that you target to, right? That's where you compile a job once, and now you want to see that, okay, how does this particular model performs on Galaxy S23 or S24? So when you submit a profile job with Galaxy S23, AI Hub will submit this job. They will procure a device, physical device on a device farm. It will run the model on device 100 times, 200 times, depending on how you choose. By default, we run it 100 times to make sure like we have all the edge cases covered and we remove all the noise. And at the end of the profile job, you see numbers like this. So the one metric we have is inference time. That shows the end-to-end latency to run the model. The second metric is memory utilization. Memory utilizations can be a very important factor. In some of our partners that we have worked in past, the memory utilization was a very key point to make sure the overall app memory footprint limited. And third is compute unit. You might wonder, how does compute unit make a difference? But that makes a huge difference indeed. Because as a developer, let's say I'm working on a game engine and I want to make sure the whole GPU cycle I want to keep free for rendering. Then in that case, if my model is fully NPU resident, then I'm certain that my model for machine learning model is not utilizing any GPU resources. So that's why the compute unit is like a very important metric to use for. So let's assume like as a developer, I'm happy with the performance because let's say I wanted 60 frames per second as a speed and I'm getting that. But now I want to make sure my model is actually doing what it is supposed to do. And actually, I would recommend running inference job before profile job, but sometimes like, I also like to change the order. And what inference job does is you pick up a model. It can be a local model, for example, squeezed NIC 10 TF-Lite, or it can also be a target model that you just submitted in the previous slide. And then you pick up a device. For example, here we have like consciously chosen a different example where let's say you use the same model, but on a S23 Ultra, and you provide a data sample that you want to run it with. Once the inference job is done, you can download the output data using a Python API. For example, inference job.download output data. Now, you can use this data and compare your model against your original PyTorch Float32 model. We haven't done any metric calculation on the AI Hub because each metric is very different. Sometimes you might want to do PSNR check. Sometimes you want to do an image check. So the metric does really vary depending on your use case. So that's why it's in the developer's hand to download the output data and then just do PSNR check very quickly in Python. We'll go over a Colab notebook that shows how you do it and why that basically makes a difference. On the below, we have few links that you can go over to read more about the options that are available for each of these jobs. Let's see a demo of AI Hub right now end to end. This is a Colab notebook that we'll share with you right after this demo, so that you can also try it out yourself, and we'll be here to answer any questions. So the first step is to install AI Hub. It's a Python package, and next step is basically to load a PyTorch model. In this example, we are choosing we choose a model called FFNet. We load the model, and then we get the input spec. Input specs are required to trace the model correctly. Then we use torch JIT trace to trace the model. The JIT tracing is one of the important factor because we want to make sure that we capture all the shape required for your particular use cases. That's why we do a JIT tracing in general. So once you have a JIT traced model, now it is ready to compile on AI Hub. So before you do this step, please make sure that you go to app.aihub.qualcomm.com and set up your account. So once you have your account set up, then you can use QAI Hub config to configure your particular account for further use. You can use Qualcomm AI Hub list devices to show all the devices that are available to you for use. For example, when I use my token, I have access to these many devices. It ranges from Google Pixel to Samsung to Xiaomi devices. It also has IoT devices in the list. So let's say if you're targeting both Android as well as IoT use cases, this comes really handy. Now, let's say I want to lock down Samsung Galaxy S24 for my rest of the demo. So I just basically create a new hub device called Samsung Galaxy S24. And I select my target runtime as a TF Lite because I want to basically generalize my target and I want to use one model for all the platform that I'm targeting to. So as we previously saw, I submit a compilation job with this simple step. The source model is a trace torch model that we just did in the first stage. I have input spec from the model itself. I pick up a device and then I put up a device name as well. So once I run a compilation job, we have ran it beforehand to make sure we save time for the workshop. This is a AI Hub compilation job page that we see. On this page, you will see the target device that we are targeting, the Android OS that was installed on a device of the interest. Let me increase the font if it is not visible. Okay. And this is the target asset that I can directly download and use. I will show this model on Netron as well. But we also have something called visualization to help you understand how this model basically look like and any changes, let's say, if you want to do. So on a compilation job, you can just see the graph, but the real trick is how does this model look like when you actually run a model on device, right? So let's get into that. So at the end of the compilation job, we are aware that, okay, model is compiled fine, and now I'm ready to profile it and do inference as well. So the next step is basically to get a target model from compilation job and then kick off a submit profile job. So once we submit a profile job, this model runs multiple times on AI Hub, and now at the end of a profile job, we see the inference time. For example, this particular model took around 20 milliseconds to run on average, and it took around 100 MB memory usage, and around 94 compute units were fully NPU resident. Now let's look into the visualization graph. I really like this visualization job in general when we have multi backend support. For example, right now all of the models are NPU resident, but if we have a split, this visualization job really helps me to understand what are the patterns that are not running on NPU. So for example, let's say if this particular convolution was not running on NPU, then at least it gives me some data points on what changes I can do in my source PyTorch model to make sure this is NPU resident. Let's go back to the demo. So once we are happy with the performance as well, then I create let's say this random data point and submit an inference job. And then I download the output data from here, and we see this on-device output is indeed computed on device. And right now, all we need is a metric that we can use to compare output data from device as well as Float32 PyTorch model. So here we have a very small function called getPSNR, which will compute a difference between two tensors. Higher and PSNR is a metric where basically higher is better. So for example, here if we compare the torch output, which is Float32, versus on-device model output, we see PSNR of 88, which is quite good. So this is one of the indication that model is indeed good, and we can actually go ahead and deploy that model. So this is a part one, right? As a model development, this is just half of the equation. Now you have a model. What next? That's where an Android app integration comes handy. So let's walk over through how do we run this model actually on Android app as well. To make your life easy, we have something called AI Hub apps. So it's a GitHub repo that you can quickly get from AI Hub website as well. We have two categories of apps in this repo. One is Android and one is Windows. Let's just walk over the Windows Android apps for this particular workshop. Right now, we can use semantic segmentation or super resolution. So I will walk you through super resolution use case for this workshop, but feel free to try all other use cases as well. So once I go to the super resolution sample app, first step is to clone this repo. Once you clone the repo, you get access to all the apps. Then in our README, we have mentioned which all models it supports as of today. But note that it is not just restricted to these particular models. You can also go ahead and integrate that with all other models. Let's try to use ESR again for this step. And Meghan showed previously how you access the model from AI Hub website. For example, if you go to aihub.qualcomm.com and then go to ESR GAN model, you will be landing to the same page. And from this page, I can quickly download the model. So let's just make sure I have all the devices selected right. So right now I'm targeting on this phone, which is Galaxy S24. So I will quickly decide, okay, let's pick 8 Gen 3 mobile and TF Lite as the runtime. And okay, this number looks good to me. So let's just download the model and see how it goes. So in the interest of time, I have already downloaded the model. The next step, so let's just go back to the README and follow through. So once we have downloaded the model, all we need is open the project in Android Studio, which I have already done. You just need to put the asset in the assets directory here. So for example, here's the super resolution.tf Lite that I just downloaded. And let's try and run it. Let's give it a second. Okay. This particular demo is very simple, where we have pre-selected some images, and you can also upload your own image. So we have this sample image here, which we selected right now, and it's being loaded. Here we have two options. We can either run it CPU only, or we can run it on all hardware. When you select all hardware, it indeed runs on both CPU, GPU, and NPU. If model is NPU resident, as we have seen on the AI Hub website, it will most likely run fully on NPU. Usually it works. Let me see. Okay, it loaded. So to show you the difference, right? Like now let's run the model and see. Now we have seen. Let's see. Seems like a bug, but okay. Okay. Hmm. The issue seems to be in rendering because we have fixed the resolution, right? That's why I seem to have some distortions here. But if you pinch the model, you can see the difference between, at least I'm able to see here, where you see the distorted image and non-distorted image. Yeah. We have another demo as well. It's called image segmentation. I think I would like to show that right now. So this segmentation demo is from same repo itself. So if you download a semantic segmentation, you will repro this model. So let's just see. I will select as NPU as a runtime, and I will start a camera, and I will point to all of you. So as you can see, we see 30 frames per second for a semantic segmentation here, right? And it's able to do segmentation quite well, looking at the numbers. This is a quantized model, so you might see some segmentation might not be correct, right? But that's an artifact of how you have quantized the model. So depending on your use case, let's say if you do, let's say, calibration during quantization, then it will work like really well for your particular use cases. For example, you're looking great, by the way. So let me show you the difference between what happens when you run this on NPU versus CPU. Let's just go back and select CPU as a target runtime. And now look at the frame per second. It's like almost zero, right? Because there are like many subjects in the frame, it finds it hard to do segmentation at a good speed. So in the best case, you will get, let's say, maybe 1 frame plus like a 1 FPS or something like that. So this demo was just to show like how NPU utilization makes a difference in performance and why maximizing NPU utilization is important in general for when you deploy on device. Like the argument might be, okay, we have a GPU, why not just use it? But then again, let's say if you have some rendering use cases, then you want to make sure the GPU is really free for those particular use cases, right? And that's where NPU comes like really handy. We do have like one more demo to show. Let me just load it up. So if you go to our AI Hub apps, we have something called Genie tutorial. It's LLM on Genie. So if you follow this tutorial, it will guide you to run all the LLMs that we support as of today on Android devices. This includes all Llama family. This includes Baichuan, Quen, and Mistral model as well. Note that all the partner models that Meghan just mentioned, for example, Mistral 3 billion is also available to purchase on our platform, but 7 billion Mistral is open source. That's why like we can also like give that model to you. And getting access to this model is like very easy. Since Llama model we cannot redistribute for legal reasons, we are giving you all the recipes that you can use to export them yourself. So getting a Llama 3.2 model is as easy as running .export from AI Hub website. For example, the ESR GAN that we just saw, you can export the models with something like this: Python-m QA Hub models ESR GAN export. And to run the Llama model is very much similar to this. Here you just mentioned Llama version 3 to be 3 billion, and you just export. And with this simple command, you will get access to the Llama family model as well. It requires like 1 to 2 hours because model is very big. And basically, and most of the time goes in upload. Let me be very clear. So if you have a good internet, you can get done within an hour as well. So let me just walk you through, let's say, for example, if you follow this tutorial, we won't go deep down into this tutorial right now. We want you to try out AI Hub right today. At the end of this tutorial, you will also be able to run Llama model on device. So we have this small sneak preview of something that will be up on AI Hub within like next 2 weeks. So we'll be also releasing a sample Android app for you to try LLM on device. For example, we can just ask it, let's ask, what is droidcon? Yeah, I think I misspelled that. Yeah, my bad. Let me rerun it. It's a demo course, you know. Actually, I like trying demos with like, it's flickering now. I will just quickly, yeah. So this is a Llama 3 8 billion model running on device. But I think there are like Llama 3 billion as well that you can try out. But yeah, I think I will hand off to Meghan for next. Cool. Thank you.
All right, so just a quick couple reminders and things that we want to share, and then if you have your laptop, you can try it yourself. So one thing I do want to mention is we have a very engaging developer community on Slack. And I'll show you quickly how to find that on aihub.qualcomm.com. It's open to anyone, and whenever you hit an issue, if you're submitting a job, a compile job, a profile job, maybe you're not happy with the model performance, just message us on Slack. We also share any new features and updates there. So we encourage that you join, and our whole team is always there looking out for any questions. So I'll show you that in just a second. The other thing I wanted to mention was our resources page. So on our resources page, we have customer success stories of other people that have used AI Hub. We have documentation, frequently asked questions, and a how-to video series in case, in a couple weeks' time you want to remember how to specify which compute unit to use, or maybe even which device you want to target. You can just watch our how-to videos that are there. So let me just show you real quick where all of that is, and then we'll start on the hands-on portion. So again, if you just go to aihub.qualcomm.com, and then you click here on the community tab, you'll see our Slack community, and then if you go over to learning, you'll see our resources page here. So I encourage you to check any of this out. We have courses on deeplearning.ai, as well as those how-to videos and some customer stories. So you can check that out later. And then in the meantime, we have the QR code here, and I will just make this nice and big for all of you and go to that slide so that you can check it out if you'd like to. So that'll link to the Colab notebook, which helps you get started. And if you don't have your computer today, that's quite okay. We also have the exact same instructions on our Get Started page on aihub.qualcomm.com. So that'll walk you through submitting, in this case, it's MobileNet V2, but you can really bring, as Bhushan mentioned, any pre-trained PyTorch model. And then you can go ahead and walk through how to submit each job to AI Hub to get all the benefits that we've walked through today. So we'll stop here for any questions, and then if people are trying it out and want our help in any way, we can also come around and help people. So if anyone has questions, we have a mic up here, and we can start with that. Yeah.
Well, it's quite an obvious question. Do you have support for Apple devices?
So we don't support Apple devices. It's only devices that have a Qualcomm chipset.
Okay. And my second question would be, what is the difference between the build for, let's say, one Qualcomm chip to a different Qualcomm chip?
Yeah.
Yeah. So if you use a TF Lite runtime, for example, then it should be all handled, because like all the compilation is, let's say, happening out on device during load time, so it will be chip agnostic. But let's say if you're targeting a Qualcomm binary in itself, then it will be a device specific. But like we have seen in the past, let's say if you build a QNN model for Gen 2 and if you run it on Gen 3, it should work. It might not be performant because it has like all the Gen 2 related the kernels, but it should execute. But it's not guaranteed. That's why like we recommend using TF Lite path, because TF Lite path is like more general in general, right? But let's say if you know specifically that you want to target this particular device, then go for QNN binary. Because QNN binary will give you like confirmed benefits, and it has an improved load time. The TF Lite has a slower load time because of its compilation nature, because it does all the compilation at load time, right? So depending on your use case, you should select the target runtime. So yeah, but like we have all the options for you. So thanks. Yeah, let us know like if you like if anybody's trying out the demo. Yeah, go ahead. Yeah.
So you said if you build the model with TensorFlow Lite, it's going to work on any Android phone that supports it, right?
Correct. Yeah.
And do you have a way to so like my app is going to support 14,000 devices, which few of them are Qualcomm or like half of them. So is there an easy way to kind of detect the chipset that I can definitely show the feature?
Yeah. So so you want to look into like how it is performant on Qualcomm chip or
Yeah. So or is it going to be not performant, and then I don't want to show it that I have it
got it
at all?
Yeah. So I think you can use AI Hub to get that performance metric, and then you can decide at your app level like what exactly you would like to do, right? For example, so if you already have a TF Lite model,
And you have like an API maybe or easy way to detect it's a Qualcomm chip that supports whatever.
so we only have Qualcomm chips on AI Hub, right? So for example, Pixel or all this like Galaxy S24, they all have a Qualcomm chip. Like that's the reason like you can basically evaluate them on AI Hub.
Right, because probably I want to do it on the runtime.
So I think here's I think let's take a step back. So for example, let's look into how TF Lite is operating, right? So TF Lite has something called delegate, and depending on which platform you have, that delegate will compile your model into that low level runtime. For example, let's say we have a simple mobile net as a TF Lite model, and you have two use cases. Let's say you have a Qualcomm device and you have a non-Qualcomm device, right? So the Qualcomm device does have a QNN delegate implemented for TF Lite. So when you run your TF Lite model on Qualcomm chip, that delegate will make sure your model is performant on Qualcomm platform. Because Qualcomm as a company is taking responsibility of giving you performance on our chip, on our platform, right? But if you choose another platform, depending on the vendor that model is built with, they might have a delegate or they might not. But if they don't, then it will run on CPU. But that's a fantastic question. So,
Right. Cheers. Thank you.
yeah.
And CPU we shouldn't run it, right? Because it's very bad.
Yeah. As we saw, right? Like 1 frame per second. So, do you wanna?
That being said, though, like it'll still work across devices, right? Because what we're here for is making sure that your model is working in your app, regardless of whether it's a Qualcomm device or not. So hopefully that clarifies it. Another question over here.
Hi. Nice presentation. This is really amazing. But on similar lines, what he asked, so suppose we are training this for Samsung. Samsung has both Qualcomm and Exynos. So my question is, let's say if a non-Qualcomm chip has an NPU, would this support that, or would this not?
So, great question again. So the AI Hub is like it's a Qualcomm AI Hub. That's why like we have all the devices for Qualcomm, right? But what we built is agnostic. I mean that can be used, but like for from our infrastructure point of view, right? Like we only target the devices that has Qualcomm chip. So we will only be able to provide you metrics for Qualcomm, but that does not stop you from using the generated assets on other devices. So, for example, you compile a model for, let's say, Galaxy S24. That will most likely work on all other Android smartphones as well. Because what we do as to compile, like while compilation, TF Lite is a very generic asset, right? That can be deployable anywhere. But since we know you're targeting S24, we might do some graph transformation to make sure that is highly performant on S24.
Okay, so as you mentioned that if it is using Qualcomm, it is going to leverage the NPU for
Yeah,
that
that's
particular.
correct. Yeah.
But let's say if it's a non-Qualcomm device with an
Exynos, for
NPU,
example.
Exynos, for example, it has NPU
Correct.
in it. So will it leverage that, or
Uh,
there's no guarantee in
So
that?
there is no guarantee. I think I'll have like similar answer, but maybe I will explain it a bit differently. So similar to Qualcomm has a delegate, let's say Samsung also has their own delegate. I'm not sure about like what exactly is, right? But it's that runtime's responsibility to make sure your model is performant on that particular platform. Because after TF Lite, there is, let's say, code generator, which is generating code specific to that particular processor, right? So if, let's say, Samsung has implemented that, then it will be benefited. Otherwise, it won't. And TF Lite is like really good in terms of the NN API, where they try to maximize the NPU utilization. So they will try for NPU first. If that fails, then they go to GPU and then they go to CPU, right?
Okay.
So let's say on Exynos it might run on GPU maybe, for example, right?
But we're not sure of.
Yeah.
Okay.
But like from our side, like I think Meghan can point more. But like we run like exclusive scorecard like every week to make sure like we are catching all the use cases for like variety of models and make sure like that we don't regress, right? And we also improve. Like for example, we started where 50% of the model were not even converting. So the converter toolchain from Onyx to TF is itself broken. So we rebuilt the Onyx to TF converter from scratch in-house, and that helps us get from 50 to 80%. Then we did like bunch of performance optimization that helped us like from getting 80 to 95%.
And that's why you'll see now we have the 125 models that we were showing on the AI Hub website. When we initially launched in March, that was around 75 models, but as we continue to make sure that models are working well, then we're increasing the number of models there. One thing that we forgot to mention, we have a couple prizes for those people that have asked questions. So in case that encourages you to ask questions, we have some goodies up here at the end. So if anyone has any other questions, let us know.
Yeah. I have a similar question. So
Yeah.
the compiling the model is to optimize the performance in a way. Usually in Android app, we support multiple different type of devices with multiple chipsets. Does it mean to get the best performance, do we need to different compile the models for
No,
devices?
actually. So I would say it's more on experimentation. Like for example, that's a great point actually. Like we'll also go back and like think more on like how we can like help you in that case. But we are constantly thinking about like this particular use case, and that's where we have recommending like TF Lite model, because like that's more flexible and that's more like deployable in general, right? But as I mentioned, if you specify device, we might do some optimizations, but it's a very, very general model that you can use. Yeah.
And the other thing worth mentioning is you can try out the other runtimes for each model, right? So you can try out the TensorFlow Lite runtime, try out the Onyx runtime, try out Qualcomm AI Engine Direct, and see which one gets you the best performance. And that's why we've built the platform so that you can experiment and you can get not only the best performance for your model, but also between the three runtimes, and then see, which one you actually want to go ahead and use. So we just want to give you the options there so that you can make the choice yourself.
How committed are you to keep on updating the newest models as they come out? Is it going to be something that you
I think let's have it on mic.
Right,
So
sorry.
it's,
So how committed are you that you're going to keep on uploading the newest models that they come out?
So if you have any requests, like you go to AI Hub and maybe there's a use case that isn't there that you're interested in, just let us know on Slack. We take feature requests all the time, and we'll add models based off of what customers are looking for. So we're always looking to expand, and we update in Slack as well when we add new models, when we add new features. Like Bhushan was mentioning, we released the quantize job only 2 weeks ago, and that lets people quantize a job in AI Hub itself. So when we have things to share, it'll be in Slack, and feel free to request anything.
Cheers. Actually, I have something to add on the TF Lite, because like since we had like multiple questions, I was thinking in the bag. So one use case like I can come off, right? Like maybe it could be we can always use OTA. Right. For example, let's say if you build a suite behind the wheel where basically you have for each particular model, you have an optimized TF-Lite asset, for example, right? And you know, like for this particular device, like I have this variant of a model. For example, on Qualcomm, let's say channel last is performing really well. On Exynos, maybe a different model is performing well. Maybe not the channel, but maybe something internal to the model, right? Then you can always have those models on the cloud, on hosted. And when a user is using in and then their Android app, you can just download the right model for their particular use cases, right? So that way you can solve this problem, right? And you can do an evaluation on AI Hub, and like maybe you can have a weekly infrastructure where you run a model on AI Hub to make sure it meets your quality bar, right? For example, we have once a month we have a new QNN SDK that comes out, right? And with each QNN SDK, your model might get better and better and better, right? So what you can do is maybe you can have some evaluation automated setup to do like monthly testing, and if model is doing well, you just roll out that to developers, like to the users, right? So like that's something like that can be set up. Sorry, yeah.
Okay. Uh, so my point of view is, so I cannot use devices like A, B, C, and then optimize the model and then deploy it for every device using maybe a check or something. Um, would it be best if we choose, let's say, a middle, not high-end chip, but a middle budget-friendly phones chip, Qualcomm range, and then I choose that chip inside this AI hub and then optimize the model? Would it be an ideal approach to have a common optimized model for every Qualcomm variants? That is one question.
Yeah.
Second is, how do we know? Okay, I'm not sure if this is the right question for you, but I'm just putting forth. How do we know this model is supported for this device or not? So I can dynamically put an if check and not show the option at all for the user.
Mm-hmm. Yeah.
Yeah, that's all.
Like both questions are really fantastic. I'm really glad you asked. So let's go over the first question, right? I think that's a very smart move. Just to brief like all of you, right? For example, the question is more about, let's say I have a Snapdragon Gen 2, Gen 3, and Gen 4 in mind for deployment for for my use case. How about I just build a model for Gen 2 and make sure that is performing the best, right? And if you run the same model on Gen 3, Gen 4, it should likely perform better. And that's exactly the trend we have been seeing. So I think I highly recommend like trying that approach. That way your model is like backward compatible as well, and you know for sure it works really well on the chips, right? But I think I would highly recommend experiment this, because it could be very case to case basis, right? But this could be your first approach that you can start with, right? But if feasible, if possible, you can always go with the chip specific models as well. Like you can also do maybe some deduplication to avoid some sort of like basically memory issues and things like that. But it is more about experimentation, I would say. And on the second, can you repeat your second question?
Okay. The second question is, how do I know the bundled model doesn't support this device, so I altogether disable the feature?
Good. So if you have a TF-Lite model, then it is always supported because we compile it during load time. So if you have a TF-Lite model, you can always ship the same model on any platform.
Okay, let me rephrase. It is supported, but it is poor performing.
Okay, so great question. So let me complete the first first. But let's say if you have a QNN context binary, then it is a device specific. And that information you can query from the model itself. So if you have a TF-Lite model, it can run on any device. If you have a QNN context binary, which is basically pre-compiled to a given chip, maybe Gen 2 or Gen 3 or Gen 4. Why do we pre-compile? Because that way you know guaranteed performance and a very low load time. With TF-Lite, you have a very high load time. So let's say if you have an app where you are you want to make sure let's say you have a game and its load time is high, you want to minimize the load time, that's why you go to QNN context binary. Then you have an issue of how do we make sure that my chip is very much right to my particular model. And that's where you can use some of the utilities from QNN API. So the QNN SDK has those API where you can get the binary and you can request if it is supported on a particular device or not. Okay. And coming to the third question, let's say you have a TF-lite model and you found that, okay, this is not performant on a particular device, right? Sadly, I think this is something that you shouldn't be doing on device, on prod, right? This is something that must be done beforehand, because when you're doing, let's say when you're loading a model on user's device, you will be running it for the use cases, right? We don't want to run the model as a cross-check on the user's platform. So I think I would highly recommend having these workflows set up beforehand itself, so we catch those cases. But you can always try to make sure, for example, it could be a case where model is very tiny, that running it on NPU might be costly. Why so? Because when you run on NPU, you're loading a model onto NPU, right? So if you have a very tiny model, it could be that, oh, you run on NPU, you see, oh, load time is high, let me just run it on CPU. So those cases actually you can do on device. And you can only do it by running the model. You cannot know without running a model. Because TF-lite is also changing. So for example, if there is a bug in TF-lite delegate itself, then it might not even dispatch to QNN, right? So there are, like, let's say 2 things that could go on fault.
Thank you, thank you.
Yeah, no worries.
Any other questions? Otherwise, we'll wrap up and we'll check out your questions on Slack when you try to submit your first job. One more? Yep.
Hi, not the question about the Qualcomm AI Hub itself, but the collab link I was trying to access.
Yeah.
Yeah.
Are you experiencing issues when you're
No,
trying
it says access denied. We need permissions, I guess.
Let me take a look.
Can you? Probably it says not open yet, yeah. I think I might know the reason. Is that link public? When you that yeah. I think you'll have to do it from your laptop. We'll update it, yeah.
But just go to like the mobile net one at the bottom, so that they can try like.
This one, right?
No, go to the slides.
Okay.
And there should be one here that we can use.
So we have another notebook that you can try. Yeah, could you please try this one? tinyurl.com demo-AI hub. It's a different model though. And so this particular demo shows how you can use export script to load the model. So let me just run it from here.
Yeah.
So you have time to capture this. And you can try the previous slide as well. We'll quickly update the link right after the workshop. So if you try it after workshop, it should work. Yeah. Yeah, let's do it. Yeah. Oh. Yeah, so actually we changed we wanted to give you like a API token. So we modified the links and maybe it's not public yet. So it should be up within minutes. But I think, so we are very, very active on Slack. So if you have any questions, you can always reach out to us on Slack channel and submit as many jobs as you want. We would like to get your feedback. The questions were really great because those are indeed the pain points. And as a AI Hub group, right, we really want to bridge the gap and make sure you can deploy the models without maybe a lot of ML knowledge, right? That's the reason we have lots of pre-optimized models on AI Hub, because it should be just grab and go, right? Let's say if you're not an ML developer, you shouldn't need to think much about the ML use cases. Could you please try the previous link again? Uh, Perfect. Yeah, I think this is fixed. Yeah. Maybe we should just.
If those that ask questions want to come up, we have some water bottles and bags in case you want one. If you don't, well, it can go to someone that didn't ask a question. But yeah, that's all we have for you today. So please do try out AI Hub and let us know if you have any questions.